So first thing that we saw, that Docker is actually nothing but a operating system level virtualization, using which if I want a machine, I can have a machine like environment on the existing laptop or a host machine. And in that, whatever that I can do on my host machine, I can do it inside this Docker or a container. And there is no restriction on where you will be running it. We can run Docker whether it could be a physical machine, or it is a machine on cloud, or it's a machine on virtualization concept itself. So everything will be working in the same concept. Okay, and we just saw in quickly overview on why exactly we need Docker, as in the advantages where now you don't have to allocate any specific RAM or the resources for it before you have to work. So on that concept, now let's try to understand exactly on what is the difference between the container concept and the regular virtualization. Because now when I say containers or Docker is all about operating level or operating system level virtualization, what exactly are we going to do and how is it different? Now, if you consider the traditional method of virtual concept or the virtualization, wherein we might be using some tools like VMware or Hyper-V, now what is that you will be doing? So let's say that now you have a machine, a host machine or a physical machine, which acts as the machine on which you're going to install on top of it. So let's consider that we have one such machine where it could be of a Windows or a Linux, anything. And in that, now you're going to install the software called as VMware or Hyper-V. So those softwares which will help us to do the virtualization is called as hypervisors. Now, using this, let's say you have installed VMware. Now, using the VMware, we can actually create different kind of virtual machines. Now, for each of the virtual machine that we create, what is that we have to do is, when you create a separate virtual machine using this tool, you will be having a complete operating system as if you are going to have a new physical machine. Just like that, you are going to have a complete operating system, and then specific to this, whatever the libraries or the files that you have, and if you want any application to be run on it, you will install on this virtual machine and then run. So that is how each virtual machine that you're going to create will be acting as a separate operating system, and for which you will be having a separate complete operating system. Like how you are going to create a new machine, which means a physical machine, same way it is going to have a complete set of operating system separately for this virtual machine. And for that, anything related in terms of the files and the binaries for that operating system you'll be having, and you'll be having the application on top of it. So like this, for each machine that you create, you will be having a separate operating system in terms of, let's say I want to create one Red Hat machine, then there will be a complete Red Hat machine operating system here. Then if I want to create a Ubuntu machine, then I will be having a Ubuntu operating system completely, and top of that, whatever the libraries for that operating system and the application specific to this. So this is how we'll be creating a virtual machine and giving it to a user to work. But the problem here, what happens is, first thing is, when you take as an operating system, it needs some resource, right? So when I say resource, it needs RAM and it needs some hard disk and the resources for running the hardware. So from where are you going to give? So since the concept is virtualization, whatever that this machine which is separate or a virtual machine needs, it will be taking it from the host machine on which it is installed. So let's say that for each of this operating system, you need some 20 GB of RAM, just an example. Now, for creating one machine, you need 20 GB of RAM, and again for this also you need 20 GB of RAM, and again for this 20 GB of RAM, because you are having a complete operating system inside each one of them. So now, for each of this, when you need 20 plus 20 plus 20, that is 60 GB of RAM, it is going to basically take that 60 GB of RAM from the host machine. So now, if you want to have 3 machines on your laptop or on your host on which you are using this tool to create a machine, you need at least 60 GB of additional RAM along with the RAM that is needed for this machine also, because this is also operating system, right? So if it is going to take 20 GB of RAM, then you need 20 GB of this and you need 20 GB of each one of them. So that's how minimum you need 80 GB of RAM. But if you want to create one more machine, then once again on the host you need to add another 20 GB. That is how you can create one more machine. So like that, you will always have a resource crunch wherein the more number of machines you want to create, then you are going to require the host machine with a very huge set of resources. So that is how you can create only as many resources that is available. Based on that, only the limited number of machines can be created. So that is one of the problem. And the second problem is, now let's say you have created a virtual machine and the user is using it. Now if a user is going to use only for a couple of hours, then the remaining time it will not be used, but as an operating system it needs to be keep running on. So that way the 20 GB of RAM, whatever I said, is still going to be used from this machine whether you are running something inside it or not. So that is how, even though the machine is idle, it will be still occupying the same resources from the host, because to run this as a separate operating system you need that 20 GB of RAM. Like this, as you have many number of machines, you are actually making sure that by allocating a specific space, whether the machine is under use or not, you're going to still use everything from the host machine. Now the same time, if you want to run something on the host machine directly to do some other task, that will also consume some kind of RAM. So that is when, to maintain all those things, you have to add more and more resource, as well as there will always be going to be a resource crunch. And then, as yesterday I was talking, if you want to replicate an environment, let's say I have used one VM and in this VM I have done some task. If I want to duplicate the same thing, once again it is not an easier task in doing it using VMware or other kind of tools. So that is when we will be moving ahead to a better operating system level virtualization. So how is it different from the container concept or the Docker concept? So in Docker, you're going to work on a similar way, but the difference is, let's say you have your physical machine or whatever machine you have. So on that, you will be having a specific operating system. Now, on top of that, you will install Docker, where using the Docker, you are going to create something like a container. Okay, container is nothing but a box. So inside that box, you are not going to keep the complete operating system, but you are going to keep only those set of files which is needed to treat this box as an operating system, but not a complete operating system. That is the first difference, where inside the container you are going to keep only the files through which you can recognize that box as a separate operating system. So that way, now in each of the box or the container, you can put some specific operating system related the basic files, and then if you go inside the container or the box, you will be working as if you are working on a separate machine based on what kind of files that you have put for that operating system. Suppose if you want to treat this container as a Ubuntu machine, then you have to put the very base file for the operating system, because every operating system will have a basic set of files. So that what we call it as bootable system. So if you put only that into this container, and then when we go inside the container, we will be working as if it is a Ubuntu machine. The same thing if I have one more container, and inside this if I put a Red Hat based bootable files, then this container will be treated as a Red Hat machine. So that is how, on top of that, whatever applications that you want, you can put inside it. So the major advantage now you see, like the previous or the traditional way of virtualization, you are not allocating any RAM for it, because you are not having a complete operating system. It is just only the bootable files of the operating system is available. So that is when If the same thing here you want to create 3 machines, you are just going to take a very minimum in terms of what you are going to run. That will be directly run on the process itself, that is on the host machine. So that is how you are not going to spend an space allocated to it. So this is the point here. So unlike the regular virtualization, in container, the resource that you're going to use is only for the resource which you are running inside the container, but not for a container directly. So that is where now you can create as many containers as you want. So there is no space or no resources allocated for it. Whereas you can treat each one of them as a separate machine, and whatever that you put inside it will be specific only to that container. And it is also easy to replicate, where if I just copy or make a copy of this container, and from that I can create one more new container where whatever that I had in this container, the new container will also have it. So that is how it's easy to maintain and replicate, and at the same time I can easily start or stop this container whenever I want. If I want to use, I'll just start it. When I don't want to use, I can stop. So there is no allocation of the resource or RAM in this. Okay, so that's the basic difference, where in the container you do not have the complete operating system, but only the bootable files of that operating system. Getting the primary difference between the normal virtualization and the container, and what's the advantage?